Hello everyone and welcome back. You are watching I Can Code Now, and in this video we will talk about modifiers in C++. So we have seen data types in C++, and data types in C++ allow us to store values up to a certain range. There is a minimum range and a maximum range of values that can be stored in each data type. And if the value that we want to store in a particular data type exceeds that maximum limit or minimum limit, problems can happen, and the problem that happens is called overflow. So by default, data types allow us to store a maximum value, and if we want to store a value that is larger than the maximum value, we can use modifiers. So basically, data type modifiers can be used for increasing or decreasing the memory size. So by overflow, what I mean is that the maximum value, if we add 1 into the maximum value gets overflowed, or the value gets overflowed, and we get the, the minimum value instead. So basically integer overflows and wraps around to the minimum value. Let me show you this with an example. So I will try to declare an integer x, and the maximum positive value that is allowed by integer is this. So this is the maximum value that is allowed, and it is a 4-byte value, because by default the integer is it takes up to 4 bytes in the memory, and 1 byte is 8 bits. So 4 bytes is basically 32 bits. So this is the largest possible value, positive value, that is allowed in the integer variable, and the minimum value that is allowed by the integer variable is the same but in the opposite direction, in the negative direction. So let me type it in quickly. So this is the minimum value, and we can add, we can have positive values up to this value. So for now, this x variable will contain this value, because it is the maximum value and no overflow will happen. To show you that, let me just print this value quickly and run this. As you can see, we can see the x value on the screen, and this is the exact value that we assigned it to. Let me close this and show you a scenario where the values overflows. So I will add 1 to the value, to this maximum value, and let's now try to build this. Now you see that we have this minus sign at the beginning of the value. This is because the maximum value is 40, ends up at 7, at this large value, and ends up at 7. If we add plus 1, or the value that exceeds this will wrap around to the minimum value, and we will start seeing minimum values and up to the maximum value. This is called overflow, and we can also have overflow in the opposite direction, and this is the problem that is caused by overflows. And if we want to store this value that is by default not allowed by this integer variable or this integer data type, we can modify this integer data type by using data type modifiers, so that this allows us to store this large value, because there are cases when we need to store large values into the data types. Let me just close this. There are certain types of data modifiers, and they're called signed, you know it all small, and they can be unsigned, they can be long, let me just comment it out, and they can be short. These are all data modifiers, and the signed one is used to is used for both positive and negative values, where we have a negative sign or positive sign, and this unsigned is used where we need only positive values, so there is no sign, because without sign this is a positive value, and we cannot store negative values when we use this modifier. Long is used to increase the size the data type takes in memory, and short is used to reduce the size that data type takes in memory. And one thing to notice here is that all these modifiers cannot be used with all data types. There are certain data modifiers that can be used with certain data types, and we'll see that we are not allowed to use certain data types with certain modifiers. In order to use a modifier, all we have to use, all I have to write it down at the beginning of the declaration, like so. I have to rename it so that it doesn't conflict with the previous variable. So this is now signed variable. With this, what this means is that integer will be signed. Using signed is the default behavior of integer. So you can explicitly say that it is signed, or the compiler will implicitly assume that it is a signed variable because this is a default behavior of integers. So in our scenario, in order to store this value in this x variable, we can either make it, you know, unsigned because our value is positive and we want to store a positive value, so we don't need this negative range, and we can use this negative range as a positive range, increasing our positive range, so you can use store larger positive values. Or otherwise we can increase the memory of this integer by using this long modifier, so that it takes more space in memory, and we can successfully store this large value in this variable. And long int is basically same in most operating systems, takes up same number of bytes, and in my operating system, as we can see, that adding this long modifier doesn't make uh, you know any it doesn't increase the memory space, and I can see through this warning. So in order to increase it more, I can use this long. This has now increased the memory size of this variable to 8 bytes, and I will show you shortly that how much memory each modifier increases or decreases. So we can use these modifiers as follow, because short can be used with integers. We will start naming these variables so that we can quickly see. Right, unsigned short, there can be an unsigned short. Let me write these sizes. So there you go. And there can be an unsigned int, which can take up to 4 bytes, but this is unsigned, so there won't be any negative values allowed in this type of variable, but it will still take 4 bytes, but all the 4 bytes will accept only positive values. And there's this default, as we have seen, this one also takes 4 bytes, but it is signed int because by default it is signed. Then this long integer, this also takes 4 bytes, and long integer are basically the same in most operating systems because both are taking 4 bytes and both are signed. And in order to increase its space, we can use unsigned long integer and rename it f. This will also take 4 bytes because but it will be all positive, just like this one here, unsigned int, and this one, both will take same space and both are same basically. But if we ultimately want to increase its memory, we can use this format, long int, and this will take 4 bytes, and this will be all positive and negative values, so semicolon is required. And if we want all the positive values, we can use this long int format, and this will take 8 bytes, but all the values will be positive. So all these Modifiers can be used with integers as we have seen. And let's see about character data types. In characters, only the possible ASCII values are one. So there are possible values of ASCII are like -128 to up to 127. These are the possible ASCII values. And by the way, ASCII is something that can be stored in a character, and ASCII is something where the integer can be represented as a character, and character have its own ASCII value, and these are only defined for characters. So a simple character, this is a simple character, and it takes only 1 byte. All right, 1 byte is 8 bits. So in 8 bits, only these possible values can be stored. And if we want to, you know, use signed character, this also takes 1 byte, and it's the same as this character because it will also take that much of, you know, that much of space because by default it is signed. And then we can also use this format. This is unsigned vector k. This will also take 1 byte, but all the bytes will be positive, so the possible values will be from 0 to 255. This is the extended ASCII, and the characters beyond 1 to 7 are like not much useful, but can be helpful in depending on the problems. So as we see, only signed and unsigned are allowed with the character data types, and then for the floating or double types, we are only allowed to use this default uh, L. Okay, this default is takes 4 bytes, and if we want to increase its size, we can always use double, which takes about 8 bytes. This is a signed and unsigned, and this is always, you know, signed. So negative and positive values both are allowed, and there's a certain range of values that can be stored in these variables in these data types. But we want to increase the size of double, or if there's a larger value, we can use this long data modifier, and this is the only data modifier that is allowed with this double data type. You can use this format. Now this will increase its size to 12 bytes, and 12 bytes is enormous. Enormous, like it can take up to 19 decimal places, you know, while the double can take up to 15 decimal places, and float can, take up to 6 decimal places. Most of the cases, in most of the cases, double is sufficient, but there are scenarios when we want to increase more precisions, and the long double comes in. So, so this is it, and we have seen that we can use, these modifiers to modify the space the data type takes up in memory. Otherwise, we can also use, if we also, we can, you know, uh, we can decide on whether we want to use positive values only or negative values only, and depending on those, we can also utilize the spaces by using certain modifiers like this signed and unsigned. Signed is the default, and if we are sure that we will never store a negative value in this variable, we can use unsigned. And if there are certain issues in the values in your program, if their values is not correctly showing, there must be a problem called overflow, and you can always refer to these modifiers to see to extend your space in memory so that your value can be stored correctly. So that would be it for now, and I will see you in the next video. Where we will discuss on more about variable, what a variable is, and how you can declare variables, initialization, and declarations, and things like that. See you in the next video. Thank you.